Hi everyone. So now that you know all of the different transformations, what we're going to talk about today is something called compositions of transformations. Sometimes you'll hear this called sequences of transformations. It means the same thing. It's basically you're going to do more than one transformation on the same image. So just to review, let's write down some keywords for each of the transformations that we've learned about, just to remind us of what each of them really is. So for reflection, we talked about how this is almost like a flip or a mirror image of our shape. A translation, we said, is like a slide. A dilation is when we enlarge or reduce a shape. And a rotation is a turn. Something else to remember is that 3 of the 4 make your pre-image and image congruent, and 1 of them makes them similar. So the dilation is the only one that doesn't preserve size, meaning it doesn't stay the same shape and size, so it is not congruent, it's similar. All of the rest, the other 3, are congruent because the shape is the same exact size and shape as it started. Okay, so again, a composition of transformations is really just a sequence of transformations. A sequence meaning more than one. Okay, so if we look at number 1, it says the coordinates of the vertices of parallelogram ABCD are as follows. State the coordinates of the vertices of parallelogram A double prime, B double prime, C double prime, D double prime that result from a translation of x plus 2, y minus 3, and a reflection over the y-axis. So what we want to do to start is actually plot parallelogram ABCD. So go ahead and take a second and do that. I'll do it on my page here. Okay, so there's our pre-image. There's our original parallelogram. I'm going to change to a different color here. So now what it's telling us to do is to take that parallelogram and to translate it. And if you look at the rule they're giving us, remember, anything that's done to the x-coordinate is moving your point to the right or to the left. So when it says x plus 2, that means all of our points are going to go 2 to the right. And when it says y minus 3, that means all of our points are going to go down 3 because the y-coordinate is either going to go up or down. So I'm just going to write right under here. This will go right 2 and 3. So you're going to take each of your points and count in that direction and put your new point. So for A, I'm going to go 1, 2 to the right, 1, 2, 3 down, and here is A prime. So go ahead and do that for each of your points. And if I'm going too fast for you, feel free to pause the video until you're ready. Okay, so your translated parallelogram should look like that. So I'm going to get one more color here. The next thing they're asking us to do is to reflect over the y-axis. Now, it doesn't specifically say to go back and use A, B, C, D to reflect over the y-axis. So I'm going to take my A prime, B prime, C prime, D prime parallelogram and reflect that. Okay, so looking at point A prime, it's already on the y-axis, and so that point isn't going to change. I'm just going to relabel that as A double prime. For B, It is, if I count how far away from the y-axis, 1, 2, 3, 4, 5 away from the y-axis, going in the right direction. So I'm going to go left 5. So B double prime would be right here. Okay, we can do the same for C. So since C was 6 to the right away from the y-axis, I'm going to go 6 to the left, and there's C prime. And D end up being right here, 1 away from the y-axis. So go ahead and connect those points. And so your final picture should look like this. And so that is a sequence or a composition of transformations. We started with our, in my case, my blue parallelogram, ABCD, translated it, reflected it, and now I've turned into my A double prime, B double prime, and so on. Okay, now the last thing it says is to state the coordinates of the vertices of that parallelogram. So over here, I don't have to worry about A prime, B prime, C prime, D prime. We're just worrying about the double prime. Okay, so if you look, A double prime is 0, negative 1. B double prime looks like negative 5, positive 2. C double prime is negative 6, negative 1. And D double prime looks like negative 1, negative 4. Okay, so we're all set with that one. Let's look at number 2. On the accompanying grid, graph and label triangle ABC with vertices as follows. On the same grid, graph and label triangle A double prime, B double prime, C double prime, the image of triangle ABC, after a reflection over the line y equals x, and then a reflection over the x-axis. Okay, so we're going to follow the same exact steps. Let's start by graphing our triangle ABC. Make sure you're labeling your points as you go. Okay, trying to make these lines as straight as I can without a ruler here. Okay, so then we are being asked to reflect that triangle over the line y equals x. Okay, so let's talk about that. If I look at that line, I have to know how to graph it, first of all. So if you remember, when you don't see a number added here, it's because it was plus 0. And so what that means is that our y-intercept of that line is 0. So put a point there. And my slope is 1, which means I'm going to go up 1 over 1. So the line that I'm plotting here is going to go right through the origin, perfectly straight. I would highly suggest using a ruler at home. I'm going to try and make this as straight as I can. Okay. So there's our line y equals x. So this is the line that we're going to be reflecting over. So if you remember, to figure out where your new points are, we have to count diagonally to that line and go in the opposite direction. So I'm going to start with point A. If I count from point A to that line, it looks like I have to go 1 box diagonally. So in the opposite direction, A prime would end up being right there. Okay, if I count B diagonally to that line, it's 2 diagonal boxes, and so B prime is right here. I'm going to draw in my line for C so you can see how I'm counting. So I'm counting 1, 2, 3, 4 diagonal boxes, and I'm going to do that in the opposite direction. 1, 2, 3, 4. So right here is C prime. Okay, so if I connect those, it should look like a mirror image over that line. So if you were to fold your paper on the line we drew, those two triangles should match up. Let me erase this line now so it doesn't confuse us later. Okay, so once you have that, we are ready to reflect over the x-axis. So again, I'm going to start with the triangle that I just drew, and now I'm counting how far am I from the x-axis. So I'm going to start with A. Looks like I'm 3 away from the x-axis, so if I go 3 in the opposite direction, now I'm down here. There's my double prime. B prime is already on the x-axis, so B double prime is also going to be there. C, let's see here, 1, 2, 3, 4, 5. So 5 in the opposite direction makes C double prime up here. So if we connect those, is what your picture should look like. Okay, so going back, what does it want us to do? Oh, we don't have to write any points down? Okay, move on then. Okay, for number 3, we have the coordinates of triangle JRB are as follows. What are the coordinates of the vertices of its image after a reflection over the y-axis and then a translation of x plus 2, y minus 1. Okay, so go ahead, plot the triangle JRB. Pretty big triangle here. Okay, so our first transformation they're asking us to do is a reflection over the y-axis. Okay, so we'll take each of our points, we'll count how far it is from the y-axis, and we'll count in the opposite direction. So I'm going to start with R. So R is 3 away from the y-axis, so 3 in the opposite direction makes R prime right there. B is 4 from the y-axis, so 4 in the opposite direction makes B prime right there. J is only 1 from the y-axis, and so there's J prime. Now I know your pictures are going to look way neater than mine because you guys are using rulers, hopefully. But that's what your J prime, R prime, B prime triangle should look like. Okay, so the last transformation we have to do is translating that triangle that we just drew to the right 2. Because remember, x plus 2 implies going to the right 2 places, and down 1. Y minus 1 means we go down 1. Okay, so take each of your points and count right 2, down 1, and put the new point. Our time ends up being there. B double and J double prime. So there's a lot of overlapping here. Hopefully my different colors help. So just a slight shift, a slight slide. And there we go. Now this one does say what are the coordinates of the vertices of its image. So we do need to write down the coordinates of J double prime, R double prime, and B double prime. Okay, so J double prime. Looks like we went to the right one. 1, 2, 3 down. So 1, negative 3. R double prime. 1, 2, 3, 4, 5. Looks like 5, 5. And B double prime. We went left 2, so negative 2. Positive 4. And that's it. Okay, number 4. So this says triangle ABC, is shown. Translate it by x plus 4, y plus 2, and then reflect it over the y-axis. Okay, so the only difference here is we don't have to plot our original triangle. They've given that to us already. So we can go ahead and translate to start. Just get a different color here. Okay, so x plus 4, y plus 2. What does that mean? It means right 4 and up 2. So every point we're going to count right 4, up 2, and put our new label. 1, 2, 3, 4, up 2. So A prime is going to be right here. There's B prime. And C prime. Not as straight as I would have liked that one to be. With that. Okay, and then it says we have to reflect that over the y-axis. So, count. Let's start with A prime. A prime is 3 away from the y-axis, so in the opposite direction. A double prime will be right here. B prime is 3 away, so 3 away in the opposite direction, ends up being there for B double prime. And C is 6 away, so 6 in the opposite direction, makes C double prime right there. So there you go. Okay, and it doesn't have us writing any points, so we're all set with number 4. Okay, number 5. Triangle ABC is shown. Rotate it 90 degrees clockwise and then reflect it over the x-axis. Okay, so we haven't done a rotation yet today. So remember, clockwise means we are turning our paper to the right, and if we are going 90 degrees, that means 1 turn. So we are going to take our paper, I'm actually going to do this right with you. We're going to turn, let's see, once to the right. And we are going to write down what our new coordinates are as we see them. So your paper, when you're writing, should look how I'm writing. Okay, so A should now be at 0, negative 5. New B should be at 5, negative 5. And my new C would be at 4, negative 2. So when I turn my paper back, I'm going to plot those points that I just wrote down. So 0, negative 5. Here, that's A prime. 5, negative 5 is right here. B prime. And 4, negative 2. Okay, so there is your rotated triangle, 90 degrees. Okay, so then we have to reflect that over the x-axis. So we're going to count. Let's start with A. So A is 5 away from the x-axis, and so 5 in the opposite direction means A double prime is going to be up here. It's very nice when they have numbers on the graph, less counting. B is also 5 away. So we're going to end up, oh, that's interesting. So B and B double prime are the same point. Okay, and then what's left? C. So C looks like it's 2 away. And so here's C double prime. your final triangle. Okay, one more page, number 6. Okay, so this says, triangle CDE has vertices as follows. Perform the composition of transformations listed. Okay, so it looks like we are dealing with the same original triangle, but we're doing all different transformations to it. So why don't we right away, make this a little smaller, let's plot our original triangle. Sorry about that, my laundry is done. Surprised you guys haven't heard my children yelling. I'm sure that will be in videos to come as they come down and play. I'm working out of their playroom, so. Okay, so there is triangle CDE. So first transformation is a translation, and it is telling me to go, what does x minus 4 mean? Left 4. And if you see y has nothing done to it, it just means that you're not going up or down any. So basically we're just counting every point 4 to the left. Okay? So C, 1, 2, 3, 4. E is now, E prime is now right on top of C. D prime is here. Okay, so there is my translated triangle. Now they want us to reflect that in the x-axis. That just means reflect it over the x-axis. Okay, so we're going to count. Here's E double prime, it's 2 away from the x-axis, so 2 in the opposite direction. D is 4 away. And C is 2 away. So there is our reflected triangle. Okay. So over here, we are going to do the same exact pre-image. So we're just basically going to replot triangle CDE. Okay, so our first transformation is a translation, and this is telling me to keep x the same because we're not adding or subtracting, so we're not going left or right any, but we're going to be going up 2. Okay, so every point gets translated up 2. Okay, so C prime, D prime, E prime ends up being right there. And then lastly, we are going to be reflecting that over the line y equals x. So we graphed that on a previous example. Remember that line has a y-intercept of 0, and then the slope is 1, up 1 over 1. So I'm just going to put some points here to help me draw my line nice and straight. It's important because you're going to be counting from that line. So if it's not nice and straight, it's really tricky to count correctly. Okay, so we are going to take the second triangle we plotted and reflect it over that line. So I'm going to start with C prime. So C prime is, I'm going to draw on these lines for you too, 1.5 boxes from that line. So if I count in the opposite direction, here's a half, here's 1, C double prime ends up being right there. Okay, I'm trying to get rid of that line for you. Oop, and I just deleted part of the triangle. Okay, hold on one second. Okay, now we're in business. So why don't we look at D prime next? So D prime is a half of a box away. And so in the opposite direction, D double prime is going to end up being right here. Okay, and my last one I need is E prime. So E prime is also a half of a box away. And so in the opposite direction, E double prime is right there. Okay, so let's connect those. And there is my reflected triangle. So again, if you feel like it looks a little funny and you just want to double check, you can fold your paper on that line and you should see that your triangles match up. Okay, the last part for today. I know this has been a long lesson, so thank you for sticking with it. You know, you're always welcome to pause it and come back if you needed a break. The last thing we're going to do is we're going to actually state which transformations were applied to the picture that we're given. Okay, so this is a little bit trickier, but it's good because it really forces your brain to kind of work in a different way. We're so used to being given the rules, and now I'm asking you to write them. Okay, so the first thing you want to make sure you realize is that the original triangle is ABCD, or I'm sorry, ABC. That would be a triangle if there was a D. So we can see that's in the lower left quadrant, the third quadrant. And so the first thing we want to describe is how did triangle ABC turn into triangle A prime, B prime, C prime. Okay, so the triangle that I'm just going to do some colors here for you. So the triangle that we're looking at first is this one. So I want to know, how did my pre-image, that triangle, turn into the one that I just colored in blue, A prime, B prime, C prime. Okay, so hopefully you're thinking it's a reflection. Okay, it looks like it's a mirror image of ABC, and that's correct if you were thinking that. But we also have to specify how it was reflected. Okay, so it's not enough to just say reflection. We have to say what it was reflected over. So in this case, it was a reflection over the x-axis. Okay, so then what we're going to do is we're going to say, all right, how did A prime, B prime, C prime turn into A double prime, B double prime, C double prime? Okay, so just kind of look at that for a second. Hopefully you're thinking that it was a slide, which is a translation. Okay, it definitely wasn't turned, the size didn't change, wasn't reflected, so translation would be our last option there. And so with translations, again, you have to give detail on how it was translated. So what I would do is I would pick a point, A for example, and count how far over and how far up did A go. So if we do that, 1, 2, 3, 4, 5, 6 to the right and up 2. So when I write that, because I said 6 to the right, that means I add 6 to x. And if I went up 2, that means I add 2 to y. And that's it. That's reflection and then translation and the rules for each. Okay, so last one here. Our original triangle ABC was first changed in some way to be A prime, B prime, C prime. So if you look at that, hopefully you're thinking it was turned. It was a rotation. This is the one I'm looking at. How did I get it to be this? Okay, so that is a rotation. Now we have to say the degree and the direction of that rotation. So you can kind of play around with your paper and turn it and see, which way was it turned and by how much. And hopefully you're seeing that if you turn your paper once to the left, you're going to get where that new triangle is. So when I say turn your paper once, that's a 90-degree rotation. And when I said left, that means it was counterclockwise. Okay, so one more thing happened. Somehow I then got to this triangle. Okay, so if you look at it closely, you may originally think that it was slid, so you might think it was a translation, but if you look at the placement of your points, the letters of your points, notice that if I were to slide that triangle down, my A's should not be where they are. Okay, so this is how you can tell if it was a reflection versus a translation. So because it's a mirror image, we're going to say reflection, and then we say over, in this case, the x-axis. Okay, that is it. Great job. Stay tuned for the next lesson.